So let's look at the law of sines and cosines. Let triangle ABC be an oblique triangle with A equal to 41 degrees, B equal to 70 degrees, and C equal to 5. Let's solve the triangle here. Now, an oblique triangle is one that is not a right triangle, and we use the law of sines and the law of cosines to solve oblique triangles or to find all the missing angles and sides. However, we must be given 3 of the 6 parts of the triangle with at least one side given, which we are here, so we can solve this triangle. Now, when working with solving oblique triangles by using the law of sines and cosines, we label the side across from each angle with the same letter, however, just lowercase. In other words, little a is across from capital A, little b is across from capital B, and little c is across from capital C. So let's mark the information that we're given on our triangle here. So we're given that A is 41 degrees, B is 70 degrees, and the side between them, C, has length 5. Now we're in what's called the ASA case, which stands for angle, side, angle. Because we are given 2 angles and the side between them, or the included side. And when we're in this case, we can use the law of sines to help us, which states the following. Sine of capital A divided by little a is equal to sine of capital B divided by little b, which is equal to sine of capital C divided by little c. But in order to apply this, we need a matching angle and side. So looking over in our figure here, because we're given C, let's find capital C. And we can do that by using the fact that the angle measures in a triangle add up to 180 degrees, which means that C is equal to 180 minus A plus B. Or C is equal to 180 minus 41 plus 70. And 41 plus 70 is 111 degrees. So this is equal to 180 minus 111, which is 69 degrees. So let's put that on our figure up here. C then is 69 degrees. And now looking at our triangle, we have a matching pair here. We know capital C and we know little c. So now let's find little a and little b. We'll begin with little a and use the fact that this and this are equal. That is, sine of capital A divided by little a is equal to sine of capital C divided by little c. Or sine of 41 degrees divided by little a is equal to sine of 69 degrees divided by 5. And now cross multiplying, we have that A times sine of 69 degrees is equal to 5 times sine of 41 degrees. Or A is equal to 5 times sine of 41 degrees divided by sine of 69 degrees. And if we put this in our calculator and round to the nearest hundredth, we get that this is approximately 3.51. So let's mark that over here in our triangle. A is approximately 3.51. And now it remains to find B, which we can do by using the fact that this ratio and this ratio are equal. That is, we have sine of B divided by little b is equal to sine of C divided by little c. Or sine of 70 degrees divided by little b is equal to sine of 69 degrees divided by 5. Again, cross multiplying, we have b times sine of 69 degrees is equal to 5 times sine of 70 degrees. And dividing both sides by sine of 69 degrees gives us that b is equal to 5 times sine of 70 degrees divided by sine of 69 degrees. And again, putting this in our calculator and rounding to the nearest hundredth gives us that b is approximately 5.03. So let's mark that over here in our triangle as well. B is approximately 5.03. All right, and this is how we solve an oblique triangle in this ASA case by using the law of sines. Thank you, and we'll see you next time.